Hello, this is Simple Math for you. Our lesson today is about proving triangles congruent by ASA and AAS. أهلا بكم في قناتكم Simple Math for you. ودرسنا اليوم هو إثبات تطابق المثلثات باستخدام ASA أي زاوية وضلع وزاوية، AAS أي زاوية ثم زاوية ثم ضلع. An included side is the side of a triangle between two angles. As you see here, the side here given between two angles. So we have to be careful. We don't have, for example, side A. We have ASA. So the side should be between the two given angles. الضلع يجب أن يكون بين زاويتين. So if two angles are formed using the same two angles, measures, and included side lengths, then there is a series of rigid motions that will show that two triangles congruent. This leads to the postulate below. If two angles and the included side, so we have two angles, زاويتين, and the included side ضلع بينهما يعني, of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So let's take an exercise here or example. Complete the two-column proof. Given WX is parallel to YZ, WX is parallel to YZ. Arrows show that the lines are parallel. توازي بنحط أسهم. وأيضا and WZ is parallel to XY. Remember, when you have parallel segments in this lesson, it should come to your mind one of two useful postulates: alternate interior angle and corresponding angle. إذا كان عندك ضلعين متوازيين في مثل هذه المسائل يجب أن تخطر على بالك مسألة الزوايا المتبادلة لأنها متطابقة والزوايا المتناظرة. So let's fill in the blanks here. What is given here? The first statement will be given and we get used to copy the given information. So the first one is WX is parallel to YZ. We just copy them. Second statement is also given. So we will write the reason is given. Third statement, angle WXZ. So where is WXZ? WXZ, which is this one, is congruent to YZX. YZX is this one. As you see, Z here is very clear. Letter Z is very clear, which means they are alternate interior angles. So they are congruent by alternate interior angles theorem. Look like letter Z, remember that. Fourth statement, also we have another pair of alternate interior angles because we have two pairs of parallel sides. So since these sides also are parallel, then this angle is congruent to that. So we will copy these angles. Angle WZX is congruent to angle YXZ by alternate interior angle theorem. So far we have two angles who we need one side matching them or included, and it's very clear that this is the side we are looking for. And as you see, this side is common, مشترك between them. So that's why we will copy that one. XZ is congruent to itself and it is reflexive property of congruence. Now we can reach to the conclusion that triangles are congruent by angle, side, angle. It's very clear. Let's solve this exercise. We have here a theater uses scaffolding to hang stage lighting. This is a real life application. The stage manager needs to determine how much electrical wire is needed to hang lights across the scaffolding from point L, from here, to point N. Knowing that LN is parallel to QP. Also, we have NP is parallel to MQ. We have also LQ, which is this one, is parallel to MP. So we have set of parallel lines here. If Mn is 4, so we have this length is 4. I'm putting everything on the sketch. How many feet of electrical wire is needed to display lights across the scaffolding? So that means we are looking for the whole length here from L to N. If we were able to prove that these triangles are congruent, means this one, this triangle is congruent to that, then we can say that this is 4. So let's see what are the information here available for us and helpful. Since the lines are parallel here, as I told you, you should think about congruent triangles. What do we have here? We have here this triangle. Angle is congruent to that. Also, this angle is congruent to that. We have like letter Z here, alternate interior angles. Also, from the other hand, let's check here. We have this is congruent to that angle. This angle is congruent to that. So we have here also common sides. Here, this is common to that, this is common to that. So that means we have congruent triangles by angle, side angles. The triangles are congruent by side, by angle, side angle. That means we can say that this length is also 4. That means the total length we are looking for, which is Ln, is 4 plus 4, which is 8 feet. Easy. Now, the other theory that we are going to discuss this lesson is proving triangles congruent by angle, angle, side. And in this case, we have angles following each other. As you see, angle comes and this angle, then this angle, this and this, then the side. Angle, then a side. Since the corresponding angles and sides are congruent in this order, then the triangles are congruent. Let's discuss this flow chart. Proof, given RQ is congruent to ST, as shown here. RQ is parallel to ST, showing by the arrows. We are asked to prove that triangles are congruent. So we have here one side given. As you see here, it's written here, RQ is congruent to ST. We have also given that they are parallel, so given information. Remember, the statement will be put in the box, the reason under that box. From parallel lines, as I told you, think about alternate interior or corresponding angles. And here, the valid is the alternate interior. الزوايا المتبادلة دائما موجودة في هذا لما يكون عندك مثلثين وضلعان منهم متوازيان. So we have alternate interior angle theorem. By alternate interior angle theorem, this angle let's see, this one RQS is congruent. This is the statement TSQ. So alternate interior angle theorem. Also, we have here angles look like vertical angles. So we can mention them as well here. And this means that we have angle, then another angle, then the side coming. And all these information lead that triangles are congruent by angle, angle, side. One may ask me that he doesn't want to use the vertical angle, he can use also the alternate interior angle. Yes, you can do that. And in this case, this angle is congruent to that as well. And in this case, we can prove that the triangles are congruent by angle, side angle. This is also valid. Be careful when you write the proof to know what you are using. Let's check by using this exercise. Choose the correct statement and reasons to complete the two-column proof. Given that angle DAC is congruent to angle BAC, DAC is this one, is congruent to angle BEC, which is this one. I'm using the same color. And we have DC, side DC, is congruent to side BC. Let's choose another color, BC here. Yes, in this triangle. Prove that triangle ACB. So we are using triangle ACB, this triangle, is congruent to triangle ECB. Oh, this one. So we are trying to look for information using these triangles. Remember, look carefully, when we are using the angles here, be careful about the vertices of the angle, the triangles. And for example, we have angle ACD of this triangle. So if some of you may tell me that these are vertical angles, they are congruent. Yes, they are, but they are not part of the angles that we are looking for. So you can isolate this triangle. You can isolate one of them. You isolate this triangle outside and slide it so that you can see what are the needed information. So let's start with the given information. The first one that we can use, as he mentioned, that angle DAC is congruent to angle BEC, and we show that with the purple dots on the angle. So we have now one angle. The side, which is BC here, is congruent to DC in the other triangle. Yani BC in the red triangle is congruent to DC in the blue triangle. And this is also given. Now, what should be the third information needed? We have now angle and we have a side. So we want one side or one angle more. Actually, for the sides, we don't have any extra information to show that the side's congruent, but we have a congruent pair of angles. What is this angle? This is angle C. As you see here, angle C is a common angle between these two triangles. It is a vertex angle, part of the first triangle, the blue one, and it is an angle at the vertex for the red triangle. And that's why we will write that angle C is congruent to itself using reflexive property of congruence. So what happened now? We have side angle, another angle. We have angle here, we have angle, and we have side connecting them. So we can prove that these triangles are congruent by angle, side, angle. Right, the specified type of proof, we want two-column proof. So we will write the statement and the reason given. Copy the given information. 1, AB is parallel to CD, given. 2, angle CBD is congruent to angle ADB, also given. And I will show that. CBD is this one, is congruent to ADB, which is this one in the second triangle. We are proving that triangles are congruent. Now, as I told you before, if you have parallel lines, then use the alternate interior angle or corresponding. Now, alternate interior angle shows that this angle is congruent to that. So we can directly write angle ABD is congruent to angle BDC, alternate interior angles theorem. So what do we have here? We have two angles and we need the side connecting them. The only side connecting them is the side common between these two triangles. Thus we can say BD is congruent to itself by reflexive property of congruence. That means that triangles ABD and CDB are congruent by what? Angle, side, angle. Another example. Given, we have also statement and reason. Given angle S is congruent to angle V. T is the midpoint of SV. This is SV. midpoint نقطة المنتصف means it cuts this segment into two congruent parts. So let's write angle S is congruent to angle V, and it's given, not a conclusion from us. Also, it's given that T is the midpoint of SV, and this is also given. Now, what is the conclusion? What do you know if this is midpoint? If T is the midpoint, then what? Then ST will be congruent to TV, and this is definition of midpoint, because the midpoint cuts the segment into two congruent parts. So we have here a side, an angle, and we know directly that this angle, let's change the color, this angle is congruent to that by vertical angle theorem. Everyone knows that now, so we will copy that. Angle RTS is congruent to angle V2TU, vertical angle theorem, vertical angles theorem. So we have here now two angles and side included, outside connecting them. So we can copy that triangle. اللي هو آخر statement, last statement, we will copy here, the needed one. Triangle RTS is congruent to triangle UTV by ASA. Angle, side angle. We have here also, we will write two-column proof statement and reason. Reason number one statement is given BC is parallel to EF, given. We also know AB is congruent to DE, given. AB is congruent to DE. 3. Angle C is congruent to angle F, given. So this angle is congruent to this angle. Let's see, what do we have? We have side, we have angle. So we need another angle or another side. But since this is as the side given and this is an angle, so we need this angle to be proven. We need this angle to be proven to equal to this, because we have angle, angle, side. We have ASA, angle, side, angle. But for the angle, side, angle, the angles should be one here and one there and the side between them. And we don't have information about that. For side, angle, side, also, side, angle, side, the angle should be between two sides. So we have only information about one side. So as I told you before, we have two parallel lines, and let's check whether we have alternate interior or corresponding angles here. Actually, we have here something looking like letter F that we studied before. This is the letter F. And one interior, one exterior angle on the same side of the transversal. So we have corresponding angle. So that means we can say that angle ABC is congruent to angle DEF. Reason, corresponding angles theorem. And that means now what do we have? We have angle, then side corresponding to each other. So that means triangles ABC is congruent to triangle EEF by angle, side. It's a very nice proof. And let's see last example in the proving. Same thing here, we have two parallel lines, so you should think about alternate interior because letter Z is appearing more here. What is given? V is midpoint of both, YW. So YW is cut, V is midpoint. So it is cut directly. So from here, from this statement, you can say that YV is congruent to VW midpoint theorem or definition of midpoint. Okay, what else given? We have also given UY is parallel to XW, and it is shown here by arrows. So we should think about angles directly. So this angle is congruent to this angle by alternate interior angle theorem. So we can say that angle UYV is congruent to angle VWX using alternate interior angles theorem. This is given, of course. What else needed now? We need an angle. We can use another angle. We can use this angle by alternate interior angle theorem. So it turns to angle side. It's okay. Also, we can use this vertical angle. So it will be angle side angle. It's up to you. Both are correct. So if you use the first choice, which is this one, so we can say that angle YUV is congruent to angle WXV by the same theorem, alternate interior angles theorem. Then triangle UVY is congruent to triangle XVW by angle side, because we have here angle. Sorry, angle. If you use two alternate interior angle, yes, angle, then angle, this side. As I told you, you can also use the vertical angle, so it turns to angle side angle. Finally, here we have one real-life application, and it looks easy as you see here. Two DOS stops have cross-sections that are right triangles. We want the right triangles. Both have a 20 degrees angle, and the length of the side between the 90 and the 20 angles are equal, so they name it X here and X there. So we have here 90 degrees because it's right angle. We have this side congruent to that one, so this is another side, and we have this angle is congruent to that angle. So that means we have triangles that are congruent. So we can answer the first questions. Are the cross sections congruent? Yes, by angle side angle. B, if each cross section has a height of 2 inches, so h is 2, x equals to 5, x is the same as our base, which is 5 inches. What is the combined area of the two cross sections? Since each cross section looks like a triangle, then we will use the area of triangle, which is half base times height. Each triangle has an area of half of x is 5, height is 2, so it is 5 inches square. So the combined area will be adding them, 5 plus 5 or 5 times 2, which is 10 inches square. And with that, we are done with this lesson about angle side angle or angle side. Remember, no AAA. There is no congruent statement or congruent theory that states that triangles are congruent by angle. This is not existing. There is no side angle also. This is not existing. So far we have angle side angle, we have angle side. We studied before side. We have also side angle side. And there is also a theory related to right triangle, but it is part of those which is related to hypotenuse and leg. But so far, for any triangle in general, these are the theories that you can use. Thank you very much. شكرا لكم لحسن استماعكم وإلى اللقاء.